Wingman. Today we're going to show you our very exciting experiment about balloon jet propulsion. We hope you learn as much as we did. Enjoy!
Question.
What is the relationship between the size of a balloon on a balloon jet propelled car and the distance it travels?
Hypothesis.
The relationship between the size of the balloon and the distance the car travels will be that the greater diameter, the farther the car will travel.
Apparatus. For this experiment, we used some tape, a toy car, a balloon hand pump to pump up our balloons, a plastic aquarium tube, an elbow pipe piece, a tape measure, a pair of scissors, 2 cable ties, a straw, a pencil, a fishing line, and balloons of different sizes. Procedures. Preparing the toy car.
To start the experiment, we first have to build a balloon jet propelled car, like this. This is the result of several hours of work, and it was designed and created entirely by us. Any design that looks similar to this is just simply a coincidence. First of all, obtain a toy car of around small to medium size. This toy car was about 10.5 cm long and 4 cm high. Next, cut off 10 cm of aquarium tubing and insert it to the car from the back window and out the front. Next, insert the curved elbow piping through the aquarium tubing. It should fit perfectly. And secure it with several layers of tape, like this. Now it will not come off. Next, loop a cable tire through the windows underneath the car to make sure that this fixture will not come loose, like this. Now cut off the remaining parts of the cable tire. Next, cut off around 3 centimeters of a small balloon, the nozzle part of the balloon. Now, wrap this nozzle around the aquarium tubing end of the balloon, the end that's sticking out the back window, such as this. Secure with a layer or a couple or 2 of tape. Now, we will now cover the elbow end of this car with a balloon, such as this. Make sure that the balloon is smooth, because this balloon will expand when air is pumped through this nozzle during our experiment. Secure this balloon with also a few layers of tape. Finally, insert a straw through the car. A fishing line will be fed through the straw to guide the car while we're doing our experiment. Now, you have your balloon jet propelled car. Now that we have finished our balloon jet propulsion car, we can now set up the experiment. As you can see, we have set up a tape measure and a fishing line. Make sure that the fishing line is exactly perfectly straight, because it is very crucial to guide the car, to make sure that the car doesn't go about in different directions. Now, to do the experiment, first of all, insert the pump through this nozzle. Make sure that air isn't leaking out. Now, once you think that you have pumped to your target diameter, this time 55 centimeters, get another person to help you measure the widest part of the balloon.
Let it out a little bit. Keep going. Stop. That's 55 centimeters.
If you haven't reached your target diameter, continue pumping the balloon or letting air out. Now, we are ready. Annika's on the other side holding the string. Also, make sure that the very tip of the car matches up with the 0 of the tape measure. Now, 1, 2, 3. What is the measurement, Annika?
Measurement is 116 centimeters.
Thank you. Now, we have completed the trial 1 of our experiment with a balloon diameter of 55 centimeters. Continue doing this experiment with try 2 and try 3 and proceed onwards with different balloons of different diameters.
Once you have completed one try, remember to change the balloon that will be pumped because it will be stretched out after being used. And this might lead to an inaccurate result. Also, change the nozzle after completing all the trials for the measurement. Experimental results. The following results are the real results that we got from when we did the experiment. The distance traveled steadily increased as the diameter increased. The 55 centimeters balloon traveled the least in average. The 70 centimeters balloon traveled the most. The measurements for all 4 diameters actually varied quite a bit. This difference was probably due to many factors, such as air resistance on the balloon, frictional resistance of the floor, the fatigue of the car's wheels after much use, and the sometimes slow reaction of the student releasing the nozzle. The 60 centimeter balloon had the greatest difference, while the 70 centimeter balloon and the 55 centimeter balloon had the smallest difference, only 30 centimeters. The measurements on try 2 were also the greatest out of all 3 trials, with the exception of the 60 centimeter balloon. Research.
By now, you might be wondering how the balloon jet-propelled car works. Before we explain it to you, you might need to know some terms.
Propulsion is to push or drive an object forward. All objects need a force, a field, to get them moving. Thrust is a pushing force to move an object. Drag is the air resistance. According to Newton's third law, for every action, there is an equal and opposite reaction. It can be used to explain the motion of a jet-propelled car. The field, the pressurized air in a balloon, ejects out of the nozzle is the action. The reaction to this is thrust, which pushes the car forward.
Newton's third law can be used to describe when the car moves forward when the air is blowing on the back. Inside a sealed balloon, the air pushes out equally on all sides, so there is equal force on all parts of the balloon. But when you open the neck of the balloon, the air rushes out of the opening.
Jet propulsion is used in jet aircrafts, rockets, NASA space shuttles, and all jet engines. It has impacted our lives in travel, war, economy, and saved lives during emergencies. And most importantly, in globalization. Jet-propelled vehicles greatly reduce the length of trips, and people can now explore other countries, know more about different cultures, learn about international news, boost the economy through trading, and much, much more. We've learned much through this project. To start with, we now realized how time-consuming and how much work it is. Being a scientist, or creating something new is. We had to draw out multiple designs of the balloon jet-propelled car and test each one to see which design was the most effective. Here are some previous designs. We really had
to rack our brains to create the most crucial and hardest part of the project, the car's design. First, by trying the balloon jet propulsion car idea with a basic balloon, and gradually experimenting with different combinations of materials until we could make a structure that was simple to pump and was efficient.
We learned that lots of materials are wasted during science research, as with the case of building a car. Now we understand why experiments are so expensive. We also popped countless balloons and used up rolls of tape, and it just ended up spending more than 300 Hong Kong dollars buying different balloons, tape, the hand pump, and etc.
Another thing we now know is that a balloon is a greater diameter will travel farther, since there is more inside the balloon under high pressure as the balloon's diameter is bigger, and the air therefore ejects out faster. We also learned that thrust is essential for an object to move, and it is the pushing force of an object. Thrust has to overcome air resistance and inertia to move. The magnitude of the thrust depends on the amount of fuel, air in this case, that is accelerated under pressure in balloon and released air.
The use of Newton's third law in jet propulsion was also something we learned. The action is the acceleration of air out of the nozzle, and the reaction to the acceleration produces a force that pushes the force of the car forward.
Conclusion.
Our hypothesis that the greater the diameter of the balloon, the farther the balloon will travel is correct. However, there are factors other than the amount of air in the balloon that affected the distance traveled. For example, the bigger the balloon got, the more air resistance there was on the balloon and the car. Also, the nozzle had to be changed constantly as it became worn down from numerous treads, which affected the results. The constant use of the car wore down the axles and the wheels because of friction. And it was observed that the car was not operating as efficiently as it was at the beginning. This may have tampered with our results. In the future, students should change the nozzle more regularly to generate more accurate results. Also, a slower release of the nozzle will mess up the results, so one should let go of the balloon as quickly as possible. One could also do this experiment with other versions of the balloon jet-propelled car to generate more difference, and we could also compare the results.
Bibliography.
I don't care if he's a nobody. In my heart, he'll be a somebody. Somebody to love me. I need it. Give me that.
Bloopers. Oops.
Hi everybody!
Sorry, I had to do
Hi everyone!
I'm Annika.
I'm Florence. And I'm Wingyan. Today we're going to show you our exciting experiment on balloon jet propulsion.
You sound like Miss Larney.
Somebody has a detention.
Your attitude needs to be better. I told you last class that you would be better.
Shut up, you
Don't be stand there. That's awkward. What are you doing filming this? You're retarded. Retarded. You should be wondering. Our science project is so interesting.
The final step to making this balloon is here are some previous designs.
Boo.
We really had to rack our brains to create the most.
Hi everyone! I'm Annika.
I'm Florence. And I'm Wingyan. Today we are going to show you crap. When you open the neck of the balloon, the air rushes out of the hole. What is the measurement, Annika?
It looks like 221.5 centimeters.
He.
And